Okay, ma'am. 1 minute. Ma'am.
Oh, okay, sir. Thank you. Thank you. Shall I start now, sir?
Yes, ma'am.
Okay. Reverend dignitaries of the great institution, respected HOD of the ECE department, dear Dr. Arun sir, dear Dr. Ravi sir, and all the dedicated Nobel professors and staff members, and as always, my dear, darling, curious kids, Andariki Namaskaram. Today we are going to discuss deep learning, the concept that has taken every sector by storm in the recent years. Deep learning's revolution is putting up a constant urge to improve already automated sectors from Tesla's self-driving cars to Amazon's grab and grow concept. Deep learning is changing the face of every industry rapidly more than ever. Remember, in our 5th day session on machine learning, I praised the sacrifices of at-home women. Today, in deep learning, my token of appreciation is for all the men in the world from time immemorial. Men take the role of fathers, brothers, sons. I am never a feminist and has not been bothered to ask the equality because of the congenial atmosphere that I was raised in. In my family, women are always respected and adored. Since I had only 2 brothers, I always played with them and their friends. I have a soft corner for boys, as boys are selfless, extremely helpful, less egoistic, they are genuine and kind. Boys take things very easy, they compromise so well. Now, as a mother and raising my son who is elder than my 2 younger daughters, I understand more deeply on how men are made up. Men are sweet and silent. They work so hard to please their family members. I have to mention my schoolmate, Prasid, the Cheta. Your sacrifice, you're far away from another country, but still you make sure that your family is taken care of. Only men can do that, and they silently do this. If it was a woman, we always, want attention. We always say it out loud. We always cry out loud. Okay. So that's how sweet you all are. So as a woman, I'm requesting all the girls that are watching me today, please don't mistake or judge the boys in your life. Boys are the coolest beings. Okay, one of the many jokes that I heard from my father when we women in our family act proud, my father says, women can make dosa at home. However, in restaurants, the family, the largest family roast are always made only by men. That's how he says. And that funny? Anyway, how true and reality strikes. 1 second. I want to show you that I could control my the fan that I have. It's I can have the cooling as well as heating on it. I can control that through my app because it has something relevant to what we are going to be seeing today. So I'm just showing you my phone. I hope you all can see. And I have the phone up. I didn't want to do this on purpose. Somehow I forgot. Then I thought maybe I could just show. See, my fan is off. The fan is over there, and this is the Dyson fan. Similarly, I can control my garage. I can control, there are cameras around the house. Then I can control the light on the other room. So many things that could be done. I'm not saying my house is completely smart, but technology has made it, electronics and all of the chips that, you are all designing as electronic engineers has helped in that. Okay, let's move on to slide number 2. Sir, you can actually, show the slides, instead of my video. Okay, there's no need for my video now. Thank you, sir. On to. This was the first slide, though, for you all to see. And beautiful place, right? GMRIT is such a serene, location. Every time I look at the photo, there's different, there's so much of trees. There's different angle with which they've taken, and I believe there's a large, it's like oasis on Earth. It's so beautiful. That's how college environment has to be. Even my college, we had we used to have it. Still, it's there. Complete trees, and there used to be yellow flowers all over the place. So such a beautiful location. GMRIT is in. Good. Moving on to our first slide. Informational slide, rather slide number 2 of the day. Cool. One look at the slide. Okay. You all can make out that deep learning understands much more than machine learning. As conveyed here, if machine learning finds out if the input is a car, deep learning goes further in providing much more information about the make, model, and the color of the car. My oath is for deep learning. I need to say, oh, I meant for men, as they have been trying relentlessly to keep all of us women so happy, and some of the women are never happy. They always complain. Please don't complain. Please encourage your, husband or, your brother, your father, your uncle, whoever it is. Okay. If every woman in the household makes an effort to keep the family environment in harmony, then this whole world would be full of achievers and more happy place for everyone in it. Okay, it's like, ooh la la. Okay, now deep learning, AI, is able to learn without human supervision, drawing from data that is both unstructured and unlabeled. As we move to an era that demands a high level, a higher level of data processing, deep learning justifies its existence for the world. Unlike machine learning, there is absolutely no need to build new features and algorithms, because deep learning directly identifies features from the data. Now, you can say why men would always be better than us, meaning like I'm talking about the ladies, like me, women rather, okay? They are all more broad-minded, deep learners rather, right? Good for them. So machine learning is just, it will just say, oh, this is a car. But deep learning would actually, have much more information. Why do we need to have deep learning? So it's like using our brain, okay? So, I wish that I spoke all this in a live auditorium. I would have loved the applause, since, we're all nearing the end of our webinar series. Tomorrow would be the last day. And I think we, covered most of the concepts, from beginner level to advanced level. I wanted to make our learning experience memorable. If every teacher, regardless of the subject that they're taking, if they make it as a fun learning atmosphere for the children, then, all the children would love to go to class. They would love to, they would remember rather, what they are learning. One of the reasons why most of my friends ask me why you chose to be in the United States, because of the education. They make children free thinkers, okay? Everyone is unique. That's how they think, they are accepted. Kids are accepted the way they are. And, they make the kids think, they make the kids think writing from, from writing to reading, each and everything, all of the projects that they do they make the kids curious, every kid, they want to, like, even in the online classes, I say, everything is live. I'm enjoying my children, being taught by their teachers here. They are being so friendly. They switch on the video all day. All day meaning during the school hours, and they always ask, like, call out names by asking, what are you doing? What do you feel? What are your thoughts on this? Did you finish this? Do you need any help? So this is just amazing. That's how, my teachers were also like that, but I'm not sure if all kids are having the privilege as me. I was very fortunate, even school and college, luck struck me. But I'm requesting all the teachers to be more friendly, more nicer, not to, intimidate children by, it could be a tough topic. If you take it well, they are going to learn well. And, we are going to create future leaders. Not just, in this world, we already aim for the Mars. So, let's conquer other, let the human race, go to other planets, and then, make our existence proud. All right, let's move on to Slide number 3. Okay. Deep neural networks, DNNs, are getting more powerful day by day in real-world tasks. These networks enable the computer to solve cognitive tasks, okay, that which most humans, we excel in cognitive tasks, but we are making the AI applications, excel. So we're still trying, such as object recognition. So the other day I just said, we were talking about facial recognition, right? Now, object recognition is similar to that, but however, we will see more. Okay, so object recognition is one, speech processing is one, cognitive planning is one, what's going to happen next, etc. So they consist of artificial units akin to neurons that are in the human brain. Okay, these units are connected to each other, and the connection weights determine what a unit computes. That is, what input features, is initially whatever input you give. These units are usually layered in orders, and then any input, okay, is activated directly. Any layer that's there is activated directly by the input. So you see a portrait of me drawn in a few minutes, okay, at New York City, Times Square, by one of the many talented artists, that can draw everyone beautifully, including me. You see? Okay. So my portrait is the input layer, is the input to the input layer, and the output layer produces a response given, okay, that the task the DN was trained on. DNN meaning like deep neural network. In this case, it's just going to identify me. And then it's going to probably say maybe she's not famous, right? I know. Just kidding. So thank God, our DNNs works on any input and doesn't have to take only the famous leaders or celebrities. That's why I want when you are trying out, please try out with your own photos. That's why I want to just, I'm not on Facebook though. I'm not in anything except LinkedIn. And even on LinkedIn, you could hardly see my face. So this is probably the closest thing. So anyways, networks that have layers between input and output layers. These hidden layers are called deep. Units that are between these layers can be connected, fed forward, and fed back. We already saw like back propagation. We already saw all of those mechanisms, right? And within a layer, whatever happens, it could be recurrent. It just can repeat, etc. Superb. Enough seeing my face. Let's move on to the next slide. All right. Okay. Convolutional Neural Networks, or CNNs. Semantic segmentation happens once. Semantic, okay, syntax, semantics of the language. All these words that are coming in, whatever you're learning, whether it's electronics, whatever, please, there would be a meaning to it. Okay, it's not like a company's name. For example, my company's name is my husband's, letters and my few letters from. But these are not like that. They have a special meaning, and there is a meaning on why that was given. Okay. Semantic segmentation happens once after the image gets recognized. That is, understanding the scenario and judging the consequence after an image gets detected. Remember the question about darknet, YOLO? I didn't follow when, I did not follow when they said darknet. I know YOLO. Because from the last, I'm talking about the last session on Friday. That's a good question, dear Nadraj Das. I have posted articles of some comments, on some, and, please refer, please. Why YOLO, darknet YOLO in C? I know you're a specialist in C because most of the questions that you're asking are C. But, we are ahead in Python because we don't even have to bother about pointers or anything. So that's why I said when we are learning Python, and especially this is a practical a Python, like a practical training on Python. So let's not even bother about more onto how C acts and everything. YOLO is you would know when the articles that I've shared has more insight on what's the hindering issue with this. Okay. In today's session as well, I'm going to be talking more about even C++ and C++. We have so many issues. Okay, not issue meaning it's great, but what I meant to say is if you were to use it in Python, not always does it work. Not all the features work. That's what my the topic on discussion. Plus, it's going to talk about more on neural convolutional neural networks. Okay, so good question, dear Natraj Das. Keep it up. Excellent. Okay, so YOLO for the others who are just listening now. YOLO, YO yellow. We generally call it a YO yellow. Because it's not like as famous as OOPS, like object-oriented programming, like everyone knows. YO yellow, that's how I remember. So meaning that you only look once. Okay, YO yellow stands for you only look once. It's an abbreviation. Alrighty. Now this is sort of like a 7x7 grid structure that becomes the input image. Object rectangles and an object category of each local region is divided by a grid, and that's sent as the output to a fully connected other layers. Now again, I would also like to there's another question, it was about the gain in electronics. Dear Toys, I'm sorry for mispronouncing my name. I think it's Toys, T-O-Y-E-S-E. I saw your comment. Okay, I saw your in the live comments. I saw your question. So please see the comments section as well. I have quite a few articles and some reference book as you asked. They are in Wikipedia. Usually when you look at the page, I have specified all of this. Let's not waste time on that. So good luck, dear. Okay, please refer to the session 5's thing. All right. Now back to our slide. Autonomous or self-driving vehicle. Our practical part of the session is completely dedicated to this. It is going to get very, very interesting, okay? So the environment around the vehicle is understood it's understood based on the cameras that are in there, all right? Now, light detection and ranging, LIDAR. You want to call it as LIDAR? I'm not too sure about how you call it. It's light detection and ranging. I left India many years ago, so I'm not sure. And I only visit my parents a couple of days, and then I stay in my in-laws mostly. So I'm not sure about what the acronyms are. And even if I go there, I talk only my native language. Nobody would know that I can talk English. So I just make sure that I speak in perfect Tamil. And I mostly dress like the person, so nobody would know. I'm not sure how these terms are called. That's what I meant to say. While I was in India, I was in I had the privilege of taking seminars, no, not webinars, in many institutions in Coimbatore, around Coimbatore, many engineering colleges. So then I would get to meet students, so I would have known. But after coming here, I only went to my college and that was it. I always go and get the blessings of my teachers, my professors. So if you call it as LIDAR, okay, but I think it's light detection and ranging. So cameras, light detection and ranging, these are, and then these are the primary things that are used in, what do I say, like cars like Tesla, okay? So, and then the appropriate traveling position is determined by motion planning. So what is going to happen next? So this is called as the semantic thing, the logic, the logic that usually when we drive, we think, okay, somebody is passing by, we need to wait. In the practical example that we are going to see today, we will get to know more. So it's going to get very interesting, okay? I can't wait to show you all that. All right. Deep learning based object detection and semantic segmentation are used to understand the surrounding environment, okay, or environment, however you want to call it. These CNNs get trained by using the images from the camera when driven by a person. This end-to-end learning-based autonomous driving control has the advantage that the system configuration is simplified because CNN learns automatically and consistently without explicit understanding of the new environment. Keep in mind, this is very important. That's the difference why machine learning, is just simple. However, deep learning is, we will expose, for example, if you're driving and if the car is in the autopilot mode, the car might not have gone to that place, but still it can understand the new environment. It learns automatically based on the training model. Alrighty. Now, rectified linear units. You see ReLUs. This is one important term. All right. Rectifier is the most popular activation function for deep neural networks. ReLUs, okay, that's how they say, ReLUs, all right, are employed mostly in computer vision, speech recognition of the deep neural nets, all right. Now, another thing that you see in this slide is batch normalization. Batch normalization is a technique for training very deep neural networks that standardizes the inputs to a layer for each mini batch. This has the effect of stabilizing the learning process and drastically reducing the number of training epochs. Remember, we saw it already? That's required to train the deep neural networks. Batch normalization after ReLU, just keep in mind, it's better to always have the ReLU, batch normalization should be after the ReLU, all right? So that performs better. So there's a question always asked whether, ReLU, these things are all, you would know, all right? So just remember, batch normalization after ReLU generally performs better. There's another thing called as the deconvolution, okay? In the red box, you see the small thing. Now, what happens here is you see those initially when there is a message, or it could be anything, it could be an image, or it could be a sound, it's actually simplified to the most, that's why you see it's from the bigger bars, it just reduces, and then finally what happens, again, we just, bring it back to the original size. So you see X8 over there, so that's times 8, right? That's the pixel-wise prediction. So this is an example for image processing, okay? That's where it's taken from. That's where it's just talking about pixel. So if it's, sound, maybe we call it as decibels or, hertz or whatever, all right? Now, deconvolution. This is actually used to create the image as it existed prior, okay, or before the actual convolution took place. In this case, we make our convoluted image again bigger in size, like I said. All right, kids, let's move on to our, not a lot of slides because I have more practical things to show. So I wanted to restrict the theory part. All right. So as always, do not worry. This is the timeline. So please don't be concerned, oh, I cannot see the fine print. Please listen, okay? In most of the webinars, even in, prominent colleges like Stanford, MIT, if you see the lecture, it's just the face that's shown, they don't even show the slides. But still from what the lecturer is talking is how we understand. So please always, all of these are available freely on YouTube, use your time wisely. And look at all of these YouTubes that are, there are so many, excellent topics that are discussed, specialized topics, and they actually upload it. This is the best time for anyone to live, We could not have been in Stanford, I can never go because I'm so busy with my work, right? I wanted to, keep on learning. I wish I was a child, but you learn from your work environment. You cannot go to, but what I do is during the, the time that I have, I always, turn on YouTube and, have lectures playing in the background. So I enjoy, the classroom environment. I even suggested, my professors, why don't you actually, because whatever they taught me is still so fresh in my mind, the way they spoke, how they wrote on the board. We didn't have smart boards back then, but still, everything is so fresh in my mind. I asked them, why don't you video, tape everything and put it so that, other generation after maybe like 10, 20 years, when you have retired, sir, maybe they will enjoy. And they said, that's a good suggestion. Maybe we have to, talk to the management about it. I know in some colleges in India, my friend is working for my very best friend from school. She is working for Sona College of Technology in Salem. She says, they have the auto camera, whatever they talk, it just goes live. So that's a great thing, because even if kids, some kids, they are maybe busy with something else, they're not there, then they can always refer back to the class, It's a great way. I'm just suggesting things where, you can, my sole reason why I wanted to do these kind of free webinars is, to anybody that asks me, is I wanted to, like share what I feel could make it, because I've seen both worlds, I have seen both worlds, and I was, very pretty good in academic, I hope. But I always paid attention to my teachers. That's what I meant. I did not, I always paid attention to my teachers during when they took whatever they took in the class. That's why it's still so fresh in my mind. Please pay attention to every word that's coming out of your teachers. So that will always stay. So, all right. Now, this slide in itself speaks about 65 years of automate, like in how the automobile industry took baby steps and how it has reached today, and why we are going to be talking about autonomous or self-driving vehicles today. Okay. All right. Now, automobile industry has evolved so well. This is the timeline, all right, for automobile industry and, those who love cars, about the most predominant, most notable developments. Okay, I really like the slide, everything in concise, so that's why I wanted to put it. Now we are hearing flying cars and fully automated self-driving cars. Advancements are happening in the fastest pace, more than ever. Ultra fast motion planning chip. Okay, it's everything. I'm not sure if you're following. People are expecting the chip that Tesla is going to release, and this, the share prices have just multiplied like anything, since these autonomous cars rely on motion planning systems running at a rate of between 3 hertz. Ease of each and everything is like from the images that are being taken. All right, so the rate ranges between 3 to 10. Now, this makes it an absolute necessity, meaning 3 hertz to 10 hertz. So this makes it an absolute necessary for the need of FPGAs. All right, all electronics children that are listening, you might be very happy to hear that, right? Field programmable gate arrays. These chips, they are capable of, configuring what, like minimum 1000 hertz or more. So going through a massive data lattice of possible, humongous data keeps on coming. When you're driving, it's live, and the car is live. Possible trajectories are happening in parallel. So what happens? You can drive, all right, you're there. Now what's happening? Hackers, cybersecurity is one main concern. So first thing that we talk about is the chip. So as electronic children, you'll be proud. Okay, there's always developments that are coming. In the news recently, I'm not sure if you're up to date with that news. I mean, I'm sure you're up to date, but NVIDIA, right? NVIDIA, the graphics card, the giant, they are going to become more giant because they are actually acquiring ARM, okay, for $40 billion. It was on LinkedIn and everything. I even liked it. This morning I liked it, but I happened to know about that news a little while ago. So the chief of NVIDIA, she is also an Indian, Indian, particularly South Indian. And the chief of Microsoft is South Indian, especially, for coming from Andhra Pradesh, your lovely state. And the chief of Google is coming from Tamil Nadu, our state. So, we all should aim high. We all should. And there's much more people. I'm not saying only if you're a CEO, you're great. Every person that works, that aims, to, work hard, all right? It could be anyone. They are great, starting from, the most easiest job we would think that they are the most, they need to be recognized more, right? I meant to say everyone that is in this world is important. We have to, like respect everyone. I always, when I go to like shops, when I go to the shop, I admire, all these men that are standing there for hours. I'm talking about India. In textile shop, they say, show me this sari, that sari. I always let them choose. They ask me what color. I say, whatever color you want, I'm just going to take it because I don't want to. Then they say, no, ma'am, we want to show you. Then I say, okay, let's, you decide for me, sir. And say, you called us sir. Thank you so much. I call them Anna sometimes, but, sometimes I say sir. And they are so happy, please make others happy. All right. Now, cybersecurity, one main concern. Hackers are always working to steal data that could compromise drivers' privacy. By revealing their the driving routes and destinations, what's happening, there is a possibilities of hackers taking control over the cars, Hence, research efforts are always in place to make self-driving cars much more safe. That's why, you hear in the news, I'm not sure if you're following again with these, when Tesla cars, they say, okay, driver was on this much miles per hour and he was, on autopilot mode and then this thing happened, that thing happened. That could be one random event, but, the media would just, like blow it up. And so anyways, that's good in one ways, but, think of all the efforts, right? If someone wants to get on the phone, at least for some time, they can actually have it in, it is safe. It is safe to have autopilot as of now. I'm not working for Tesla though, but I'm saying there are research efforts that are being made, and soon, as shown in the time slide, this is going to be something that many years ago, GPS, right? When we drive, usually they referred maps. So then GPS became a specialized feature. And when we bought our car, we had to pay like more than $10,000 just for that. That was inbuilt. But nowadays, it's common. Any car has that, right? So let's move on to. So that's what I meant to say. The technology keeps on increasing, and by as projected, it says in the last thing, 2032, they're saying half of all new cars are going to be autonomous. Awesome. Can't wait. Okay. This would be, I believe, the last slide of the day before we move on to our practical session. Now, motion planning system for vehicles. All of the slides concentrate on one, deep learning, that is in self-driving vehicles or autonomous vehicles. That's why I just chose to restrict my focus only on this today. And we pretty much, covered all the concepts. Whichever one we missed, like ReLUs and everything, I thought I would brief today. So now, motion planning system for vehicles. Okay, this begins with an enormous pre-computed graph consisting of all the different trajectories that the vehicle could take in an obstacle-free environment. This graph of all trajectories is often referred to as lattice. Okay, perception data from cameras. Okay, perception, how a real person, like a human being can think, right? So data from cameras, radar, LIDAR, and other, LIDAR and other sensors is fed into the system, which identifies static obstacles like buildings and trees, all right? Deterministic moving obstacles like pet dogs, stray cats, soccer balls. Think of all this, okay? We need the sound as well as the cameras. It could be very little, but poor little, animals here, they get struck. Like small squirrels, they escape, but, some other animals, we see that they're struck when. So all this, could be saved, I mean. A real, when a person that's driving cannot have vision, like we always say, like look for the blind vision, you have to turn left because we have just the opposite of how we drive in India here in the United States. So I say just look left and right and look at the rear camera and everything before you change lanes. Now, all of this has to be envisioned by our autonomous vehicle, right? Now, if there is a pedestrian, there is a bicyclist, other cars that are coming. So all of the perception data with the of static and deterministic obstacles. Okay, these deterministic obstacles, they actually get modeled as large static objects. Okay, and then they get dropped into the lattice. Now I think, do I have another slide? No, I think that's pretty much it. Okay, so with these obstacles are given very high costs. Remember, we saw the cost function. Because our vehicle under consideration, it must follow them, you know, that there could be any obstacle coming from anywhere. Okay, so because when we are live on the road, you know, it's not a test drive, right? Even test drive meaning like somebody that's driving to see if the car works well. It's not, I meant to say, it's not like when you take a driver's license in India, you know, they take and they don't, I'm not sure if they make you, I'm not sure about different parts of India, but at least in Tamil Nadu, in Coimbatore, they make you drive in a place where there are not much pedestrians or anything. But in New York City, it's very tough. Oh my God, they let you drive on real road, okay? We have to be there. I failed the first time though. And then the second time I got it. My husband always, you know, smart guy. So he passed the first time and then I failed anyways. These systems, these autonomous vehicles should never fail in real time. That's what I meant to say. They actually sent all this information is into the lattice. They get all these static objects, all these, you know, obstacles, they are actually sent to the lattice objects. In this slide, you see, the different color one, the pink, the, you know, the fluorescent yellow or the green, whatever you want to call, all of that, you know, you see how it actually changes that. You have to predict all of that. So this is what we do so this exact scenario would happen in New York City. I got it near Long Island City. They usually, you know, let us take the test. Oh my God, it's one of the nightmares for many kids. I know some people, they failed 8-9 times. Some boy, I don't know, somebody. He just was in the same driving school along with me, and then he came there, and then he got the thing, and then he says, Miss, you are my lucky charm. I failed 8 times, and this is the 9th time. So think how, you know, difficult it is to drive in this kind of you know, road, and especially when you're taking a driver's license, you should not error. Okay, no error should happen. Same thing with these kind of autonomous vehicles. All right, they are what? They have to vision all of this, you know, they have to predict, they have to, you know, so many things going on. Now, we are going to be seeing autonomous driving simulator called Carla. C-A-R-L-A, Carla. Nice name, no, right? This is open source. The simulator is open source. The you know, the simulator's core modules are written in C++. Okay. Now let's just get into today's you know, practical session. I want to just end this over here. Now let's see. Okay. Sir, can I stop sharing this screen over here? I'm going to be doing it from the other laptop. Okay. Just a moment. I'm going to just 1 second, kids. 1 second. Just. One moment. I'm getting into this, sharing my. There's so many things that are running here, so that's why it's taking a while for me to connect. Okay, I'm going to be showing you my entire desktop. Okay. Now, is everyone able to see?
No, ma'am.
No? Okay, one more second. Because I see the red thing, it says it's broadcasting already. That's why I wanted to confirm, because I'm parallelly checking it the other one and it's not showing me. That's why I asked you. 1 second, sir. Let me try to get back in. Maybe should we give it a few more seconds, or because it says that it's sharing. Or maybe I will exit and then get back in. Okay, no problem. Okay, let me get back in. Sorry. Okay, I try to join back again. Let's see. Now you think it's clear, sir? Is the screen coming? I think it's coming. I see it in the other thing.
No, madam.
No, madam. No.
It should be there
Yes,
now.
madam.
Yes, madam.
Because it's here, so I'm able to see it already. Okay. All right. Now, we are going to see this most interesting thing. I can't wait. I became a kid already. I love this. Oh my goodness. Ever since yesterday, I am all excited. Now I know why my kids, they love gaming. Okay. What you see in here, you see, this is our Carla environment. Okay. This is our simulator. Okay. It's an autonomous driving simulator. Okay. Now, I'm going to show you how I got in here. Let me go to, let's just go here. Let me show you. I have these modules running from, I have so many things open. Okay, yes. This is going to be too little. Anyways, kids, let me just show you. Look, I have Carla UE4. I'm not sure if you're able to see that. That's why I actually copied this in Notepad. You see Carla UE4. You see this? Okay. This is our executable that's running. Now, for you all to know more about Carla, this would be this, right? I'm just going to show you this, the one that I just highlighted now, Carla's, documents. I'm just going to show you. Let me show you. Okay, so this module was built, well, it's coming, let's talk. Okay, this was built from scratch. Okay, this is built in C++. C++, and it uses scripts or examples in Python. Where is that? Okay, I think I already have it open. I'm a good girl. Nice. I forgot that I opened already. Okay, see here. So this thing, where is that? Okay, this thing right here, this link, right? This link is what I've given. I'm not sure if you're able to see. That's why I wanted to paste it in the notepad so you can see it a little bit bigger. So Carla is a simulator that was written in C++, and we are going to make use of this in Python. Now, what happens here is, we are referencing some of the modules that are written in C++. And when you read the requirements, they say that you need it requires GPU. They say get on to that whenever you have a moment. So that's why I let that WordPad be there for some time, so you can the Notepad be there for some time, so you can actually type it and then get on the site. You have like explanation, and it has more details on what you would do, everything. Now they say that they requires GPU. However, I am just running on my laptop. Okay, this is regular CPU based laptop. This does not have a GPU, but still you are able to do that, so you can try it out. That's why I wanted to say. Now when you and there is another one that I wanted to show you. This one, this thing, the next one is you go to the creating a standalone. Just when you scroll down and you toggle down, it'll be there. Anyway, let's not focus more on the theory part. Let's get practical already. So let's just one more important thing I wanted to tell you or share you was, this did not work for me in Python 3.8. It stopped working. It stopped working means it would come. This one, this Carla UE4 would perfectly work fine. However, I would not be able to run any other things. For example, I'm going to be just you look at this environment, right? This environment is going to change now. You see, I started running the weather module, okay, and there will be a change to the weather module in a few seconds. You see, isn't that awesome? I'm going to maximize in a little bit, since we are still, like toggling and still we are understanding what this is all about. That's why I wanted to show you. This is the code. Let me talk about the rest later. This is what I ran now. This thing that I'm highlighting, I think I'm just, thinking that maybe if I highlight, you won't be able to see. So PY is, I'm trying to run the Python script that is named as dynamic weather.py in 3.7 in Python 3.7. So you all know that I had Python 3.8 since the beginning. We were talking about, see, look at this. I have the IDLE Python 3.8. I didn't want to uninstall my thing. There was a question from some kid on the first day, I believe. He asked me, I have 3.6. Should I go for 3.8? I said, it's up to you, but I don't see much difference. Since for this webinar, I had installed a couple of things on this particular laptop, so I went for the latest version. So usually it again depends on our requirements. Now, this software that we are using, Carla Simulator, does not work in 3.8. And I had to install 3.7. So that's why you see there are two IDLEs. Now, for me, then how do I invoke the modules pertaining or relevant to 3.7? I give py-3.7 and I give whatever file, whatever script that I'm trying to run. So look at that. I want you all to admire the beauty of this script. So remember, I always said C++ is amazing. Yes, it is amazing. All of this mostly. This module is just, return from scratch in C++. Since it's open source, you can have when you download, you have the code. So I had a lot of hiccup yesterday when I tried to, get this running. It was throwing exceptions and everything. I had to debug. I spent my whole Sunday on this. Poor kids, they were just, abandoned. They are saying, Mommy, when are you going to be done with the webinar series? Anyways, I want to show you. Look at this. So I didn't want to delete anything. Since I wanted to show you what all hiccups I faced, I wanted to just show you. So it's not as simple as you see. Because okay, you might ask me, why can't you just read this? Yes, I read this. Okay, they said that this would work in Python 3.5. You know, they said, you know, what did they say was they said this works well on Python 2.7, and this works well on Python 3.5. However, you know, I was able to run in 3.7, but I didn't know that, you know, I was under the pretext that it's going to work perfectly well in the newest version. However, the modules that are being referenced in the core code in Carla module, in that module, right, is not going to work. It was throwing. It does not recognize. When I said even not, you know, I did not say it. You know, when I tried to do like import Carla, I could not import. You know, it was throwing X error. It says unidentified things and all of that. Now, so I thought maybe it was something to do with my installation. Then I thought I would get another, because they said Windows version of this is, since I'm running this on Windows, right? They said, you know, Carla environment for, while we're talking, I want to just start one more thing. And then I will, because it's going to take a while. So let's just, yes, I'm going to be doing this. Okay, so this was the first thing that I tried. I'll let you know what I'm doing now. Okay, what I meant to say was I had two different, let me show you. Where is that? Let me show you. Again, these are finer print. So I have two different installations of the Carla itself, you know, two different versions of Carla. They have, you know, versions ranging from some to, you know, I believe the latest one is 0.99 or something like that. So you can just go on to the site that I initially mentioned. Over here, this is the site, right? Carla, this one, Carla, okay? This site, Carla read docs, and then get in there. And then I also had difficulties with my Pygame and NumPy. So there was so much confusion. So look, when I ran the script that when I ran this, I said, remember, I was going to start something. I ran this. This is another script. Okay, so we are doing this is threads, you know, again, what's happening? You know, I'm running different thread. Remember, we saw on the first day itself, we saw what, like initially, what did we say? We saw client server architecture. This simulator is also using the client server architecture. Okay, initial first day session, we saw HTTP server. In addition, we also know that our Jupyter notebook is also based on the client server architecture, right? And the local host is 8888. You know, that's all for Jupyter notebook. Here, Carla, this is also client server architecture. So this, see, somebody is walking. Isn't that cool? I like that walk. That's so realistic. Okay. So I'm going to do one more thing. I'm going to do one more thing, and we're going to do a little more talk. Let's do. Okay. All right, the coolest part of this is this. Okay, let's do the talking, right? So what's happening here is, you know, like I said, I thought I was going wrong on the version, something, because in the site, in Carla's website, they said Windows is actually experimental version. Then I thought, okay, something has to do with this, and I have to actually, you know, like make sure that I get the right one. So why don't I just go for the stable version? Likewise, I just kept on trying many possibilities, and finally, again and again, I mentioned GitHub and Stack Overflow, right? So in one of those sites, in Stack Overflow, right, where somebody has mentioned, okay, this is strictly not going to work in 3.8. Then that rang a bell. Why don't you just try 3.7? You see some car is going, right? Let's see, where is my... Okay, I'm expecting something else to run. Okay, is it still working? Let's see. Oh, I was in a different, see,
What is it? No module named Carla. Again, I got the same error, huh? Let's see. Okay, let me show you. This is too little for you all to look at. I need to have this. I'm so sorry. I can't help. I know I can't help making the letters big. This is dynamic weather. And why don't I run it from there? I want to just okay, what we're trying to do is we are trying to actually have the simulator, you know, like we're going to have like as if we are sitting in the car and we want to see the car go. Okay, that's what we're trying to bring up. Okay, and then I'm facing a similar error. Okay, let's just say this is good. I spawned 10 vehicles. Okay, that's great. Now, okay, let's just see. All right, let's just, so this is my dynamic weather. Okay, I wanted to interrupt that. I want to use this environment and then run my manual control because in here, everything was working fine. So I just wanted to do it like that. Okay, while we talk. Okay, I think it's going to come. In the meantime, I'm going to show you one more site. Okay, this is Pythonprogramming.net. Okay, he is again a famous YouTuber. He has this thing. Look at that. When I had the issue, I was looking for various places. Anyways, I always like this person's videos. They are very detailed, and then he types and he talks. He is also my one of my connection. You know, these people are good. They when you try to connect with them on LinkedIn, even though I don't know him in person, he is one of my LinkedIn. I am one of his numerous connections. Let's put it that way. Okay. Now let me show you. This is the site. Pythonprogramming.net, and then this is the site, Pythonprogramming.net, and then you would be able to see so much of things that he has spoken about. As a matter of fact, he is actually talking about self-driving cars with Carla and Python module as well. He is actually, what's going on? Why is that taking a while to come? It's again having the same issue. No module named Carla. Okay, let me see what's happening. This is perfectly working fine. Okay, let me show you guys one more thing. Okay. So in here they said that I have to keep the hosts in here. They said that I have to keep the TCP ports of this particular host, since it's running in a local host, they said, I have to keep the ports 2000 and 2001 available, and, the connection should be fine and everything. I wonder why it's not, like showing, it's not coming up now. Let's see. Let's see. If it's not coming up today, then I will, make sure that I debug it and, like bring it up tomorrow. Okay, now it's working. I wonder. Oh, perfectly. Just in the nick of time when I said, I would make. Okay. While it's coming up, I want to show the code. Oh, it's exiting up with an error again. It's exiting. Okay, no, it's connected. Hope it's coming. Where is it? I don't see it up yet. Let's see. If it doesn't show up, I'm going to just explain today, and tomorrow I'm going to be showing you that. Anyways, it's 8 o'clock. I'm going to show you, I was going to explain the code a little bit. Now, let's go in here into the modules. You see, these are all the cars that I spawned, you know, meaning like I actually, this is again fine print for you all. Now, what's happening here is initially when we called upon Carla UE4 executable, we got this, you know, the thing working, you know, in case you want to move, you can move. It's going to take a while for it to move. Since even the other process is running, let's see. Make sure that the simulator is ready and connected. The simulator is ready. Should I just start again everything? Okay, maybe, you know what, people, let's just close this and I'm going to be starting this again. Let's see. Let's see, just give it one more time, one more moment, and let me see. If not, I'm going to show it to you tomorrow. Look, let's just run this exe. This is the exe, this is the simulator. So I think it's saying that it's not able to understand that there is a sorry, this is, oh, I see. I think I'm in a different directory. That's why. Okay, now, because I said I didn't delete anything, you know, there's so many. No wonder why. Huh. This is the environment that it was working fine. Let's just go in there. Let's see. So many things over there. I wanted to, okay, now I want to just do Carla. Okay, now, okay, please bear with me. Sorry. Since I had many versions of Carla, many versions, you know, like, because I wasn't sure, because since most of it wasn't working well. So let me show you guys, the kids, the code while it's coming up. Okay, I want to just go in here. And then I want to show you maybe let me reduce the load of this. Okay, I want to get rid of this. And this is installation thing. I want to also get rid of that. Anyways, you all saw that. And let's see. Okay, so okay, this is where the core module is. And then these are the examples. Now, the first example that we saw was the dynamic weather. Okay. Meaning, remember I showed you from day it became night, and then, you know, in a little while it's going to be you know, like raining and all of that. Look at this highlighted thing. Okay, I'm not going to highlight. With the highlighting, it's difficult for you all to see, I believe. So there is a reason why we saw OS module, sys module, and everything. What is happening here is this green thing. Sorry about that thing. Okay, I'm so sorry. Sorry about the jarring sound. Okay, I don't know how that came. Sorry. Okay, just look at this. What I was going to say was this particular EGG file. This is the executable that we got as such from the C++ Carla module. You know, the Carla's simulator module. Now, is my thing running here? Is it still coming? Everything was perfectly working for me. Let's just see. I want to reduce the load of this. I want to just get rid of that. I don't need that. And I don't need this. Sorry about the wait, kids. You know, we thought it was going to be a breeze. And okay, hope that it got rid of the vehicles as well. Let's just do this. Let's see. So while it's coming, let me explain the code. Okay, let me explain the code. So now, once we understand this environment, okay, I'm importing the Carla class, and then this is our code in here. This part is our code. Okay, I'm not going to maximize this because, you know, I'm still checking if the Carla's module is coming up. That's why I don't want to maximize this, in case you're wondering why I'm showing it a little. I'm waiting for the thing to come. It came before, and then what's going on now? Oh, gosh. Okay, it's still coming. It's still coming. It's taking a while. I don't know why. I ran it and it was so beautiful. I wanted to show it so beautiful. Okay, good. It came finally. Good. Maybe I should just see this. Okay, let's not toggle here and there. Okay, and then I'm going to show you that I spawned the vehicles. Okay, I'm going to show you. I'm going to be running that. I want to make sure that this is the right directory. Where is this? Where is this? This is my deep learning 6 autonomous and then Windows Editor Core. Okay, I'm in the same thing. And then I'm going to be running my, so I have the environment here. You see that came, and I'm going to be opening my, you know, I'm going to be putting real-time vehicles. Okay, let's just look at the vehicles that are coming. And it usually starts with the person coming out, and then, you know, we see cars. And I'm going to be also running the, weather module. Okay, I'm in the right directory here. Let's just do, yes, I'm in the right directory. I want to make sure that I do the manual control. Okay, let's just do the talk. Okay, I'm not going to change anything here. Okay, so the way it works is it actually, you know, is a server, like server client architecture, like I said before. And this is the server, the Carla UE4, the simulator is the server. And then all of these client code that we are talking about, you know, the spawn, meaning like it is going to put vehicles. Did it put vehicles? Let's see. This is the place that I ran. Is connected. Okay, let's just see one more time. Is it working now? This has to go in sync. I don't see much cars. I don't see anything yet. Tomorrow also, thank God, we actually wanted to do Pygame, and we wanted to do, was that, you know, a little bit on, you know, the GUI-based Tkinter, okay? Tkinter and Pygame. So Do I see an effect in the, I see the water moving, I see the clouds moving, I don't see the cars happening, so it's just this that's there. I don't see the client because it's saying it just waited so long for this and nothing happened. Let's say I want to reduce the load on this. There's nothing much here. Yesterday I had so many zillion things opened. Let's see. I want to even get rid of that. The shell. And maybe this. Let's see. Let us see. Okay. Manual control. Just one more time. Please, 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 please. Please. Oh, what is the issue? Make sure the simulator is ready on this port. It is ready on that port. What are you talking about? Oh, I am so sorry, kiddos, for the difficulty. I'm going to fix this issue, and then, you know, tomorrow we're going to see this in action because it's already 8:12, meaning it's already past the time. It's 8:12 over here. I'm sorry. So I'm going to show the initially when we start, we're going to start viewing the simulator. And we're going to, you know, have the weather module, the spawn. We're going to do all of that, and we're going to see how this cars would actually go. There is some problem. If there was time, I could have, you know, like closed up everything and then rebrought everything. I didn't want to waste time. I had it up and running since 6 in the morning for me here. It was working fine, but I wonder why. So I'm going to be checking it all, and then tomorrow we're going to join again. Please, tomorrow is the last session. I was going to show you a few other games. So I'm going to make sure that I show this first, and then I'm going to show the other games. Okay, this is the most interesting game out of all. Okay, sorry that I could not show the simulator. You know, I wanted the experience of us sitting in a car and then the car driving around the city. It's such a beautiful thing. I would fix it, and tomorrow we're going to see. Okay, thank you so much, and my apologies. My apologies. Thank you. Thank you, sir. We're going past time. I want to restart everything. I want to restart this process. It's going to take at least 10 minutes. So it's going to get delayed for them for their next session. That's why I don't want to keep them waiting. Okay. Thank you very much, everyone. Sorry, kiddos. Please hold on to your curiosity. Tomorrow, you're going to definitely see this. Okay. Thank you. Yes, sir.
There are few questions.
Yes. Oh, what are the questions? Yes, sir. Definitely.
Okay, right. Sharing.
Yeah. Okay.
Is the screen visible, madam?
Yes, sir. Yes, sir. It's visible.
So these are some questions asked by same person, Shivaji.
Okay, sir. Oh, okay, sir. If my program crashes with that database open, it gets corrupted. How come? How do I write a function with output parameters called by reference? Okay, I'm going to be actually, because these are all detailed, I'm going to be sending in links to them. And, you know, he can always reference, because this is like more of coding help. So I will definitely help. Okay. And so everything's from the same person. Okay, no problem, sir. I'm going to actually, you know, like reply to him, either today or tomorrow. I want to make sure that my Pi game, this thing should work. Otherwise, I can't do anything else. Okay. So what are the main features that can be done by Carla? So tomorrow we're going to see it, and you would know. Thank you so much, sir. Thank you, sir.
Thank you, ma'am.
Thank you, ma'am. Thank you.
I'm going to be replying to Shivaji Avi, and for Shubrat, tomorrow he's going to be seeing the features and everything. Okay. It's not there are no features, it's just the environment that's created, and it will give you it's a simulator. You can sit and drive in a car, and then if you choose autopilot, what's going to happen. It just works so well, even in the morning. I don't know, I have to do something about this. And then tomorrow morning straight we're going to see this. Maybe I'm going to cut short the slides. Slides are boring anyways. We saw pretty much everything. So all of those theory part, we have to get practical. So tomorrow mostly it will be practical session. Maybe I'll put a couple, like 1 or 2 slides for tkinter and talk about Pygame a little, and that's it. Okay, sir. Thank you. Thank you so much. Sorry. Please, hold your curiosity. Tomorrow it's going to work. Okay. Thank you.
Thank you, ma'am. Thank you for
Thank
your
you, sir.
question. I thank all the participants for joining the 6th day. Tomorrow we can see exactly at the same. We will meet exactly at the same time at 4:30 p.m. Thank you. Thank you, one and all.
Thank
No.
you, sir. Thank you. Thank you. I appreciate it.